So yesterday we learned how to use the properties of a rectangle in order to solve equations about rectangles. Today we're going to learn how to use the properties of a rectangle in order to prove that any given quadrilateral is indeed a rectangle. So remember this chart that we have of all the properties of a rectangle? In order to prove that a figure is a rectangle, all we need to prove is that opposite sides are parallel and that the figure has 4 right angles. Remember that. You only need 2 pieces of information to prove that a rectangle is a rectangle. Opposite sides are parallel and the figure has 4 right angles. So I put a little screenshot of that picture right down here, and we can use it to solve the problem up top. So we need to determine whether we have a rectangle or not given the following points. So let's plot those points. We have D is here, somewhere out here. I know we don't have 9 things. F is somewhere out here, and then 5 up. 1, 2, 3, 4, 5. G is -6, and then 5 up. And then H is -6 over, and then 1 up. Okay, so now I connect my lines. Now how can I prove that this shape is a rectangle or not? I will use these 2 criteria down here. Opposite sides have to be parallel, and the shape has to have 4 right angles. So how do I prove that opposite sides are parallel? I find the slope, right? So I write over here, and yes, you do have to write it, and the reason why you have to write it is because we're training you how to write answers on the MCAS in order to get full credit. So this is how you explain and prove whether a shape is a rectangle or not. First, write out opposite sides are parallel. Now we're going to prove that part. So we want to first prove that FD is parallel to GH. So we will find the slope of line FD, and then we will find the slope of line GH. So I'm not going to go through the whole steps of putting down the formula and naming x1, y1, x2, y2, because at this stage in the game, you should already be able to do that on your own. So I'm just going to solve because I don't have much space. So the slope of line FD, we have -1 minus 5 over 9 minus 9. I'll put the formula here. M equals the change in y over the change in x. Okay? So we have -1 minus 5 over 9 minus 9. We get -6 over 0. Now remember, we can never divide by 0. So this slope is going to be undefined. Which makes sense, because look at the line FD right here. It's a line that goes straight up. So it's a vertical line. So having a slope of undefined makes sense. Let's find the slope of GH. We have slope equals 1 minus 5 over -6. Yeah.
I didn't come to school.
Uh-huh.
And when I came, I had a meeting and I have to go. I just want you to check the homework.
Yeah, I'll put it in. Do you understand?
Because I don't want to...
You understand what to do though?
Yeah, these ones.
Oh,
I didn't
okay.
understand these 2. I was confused because the X2.
I do this one in the video. Watch the video, okay?
Okay.
Alright. Good, good.
This one, though, that was the same of that one. Of the...
Alright, we want you to practice though, so you gotta finish it, okay? Do these 2 tonight and I'll give you checks left, okay?
Okay.
Bye, Angie.
Thank you.
Yeah.
You too.
So now we have 2 slopes that are undefined. And this makes sense, right? Because look at this line. It goes straight up, so it has an undefined slope. Two undefined lines have the same slope, so therefore they are parallel. So we write yes, parallel. Now let's prove if the opposite lines of GF and HD are parallel. So we write out GF is parallel to HD. And then we do GF here. And we get slope equals 5 minus 5 over 9 plus 6, which gets 0 over 15, equals 0. Remember, this is 0 divided by a number, so we can go ahead and divide and get 0. And that makes sense, right? Because GF is a completely flat line. Any flat line has a slope of 0. So far, all of our answers are making sense. But a slope of 0 is what we have for GF. So let's see what the slope of HD is. HD here. So HD, we have slope equals -1 minus 1 over 9 plus 6 equals -2 over 15. These two slopes are not the same, so they are not parallel. And therefore, we just stop. We don't need to prove the second part because we already proved that the first one is not true. Therefore, we do not have a rectangle. So we write not a rectangle. And while this shape didn't turn out to be a rectangle, it's really important to see the connection here that an undefined line will always make a 90-degree angle with a slope that is 0. So interesting to note. Just keep that in mind, okay? An undefined line and a line that has a slope of 0 will always intersect at 90 degrees. Let's do another example. So here, we need to determine whether we have a rectangle or not. So let's plot the points for the figure. We have D is -4, 1, 2, 3. DF is -5 and then 8 up this here. F. G is 6, 9. And then H is 7, -2. Okay. Let's connect our points. Oh, that's not good. Okay, there we go. Okay. And now what are the two things we have to prove in order to prove this is a rectangle? We need to show that opposite sides are parallel and the shape has 4 right angles. So first we write out 1. Opposite sides are parallel. And then we prove case by case. So first we prove that FG is parallel to DH. And we find the slope of DH, and then we find the slope of FG. The slope of DH, we do -2 plus 3 over 7 plus 4 equals 1 over 11. To find the slope of FG, we have 9 minus 8 over 6 plus 5 gives us 1 over 11. And great! These lines are parallel because they have the same slope. So let's prove whether DF and HG are parallel. So first we find the slope of DF, which is 8 plus 3 over -5 plus 4. It gives us 11 over -1. Okay. Then we have the slope of HG, which is, 9 plus 2 over 6 minus 7, which is 11 over negative 1. And yes, these two lines are parallel because they have the same slope. So far, we have sufficiently proven this part. Now we need to prove the second part, that it has 4 right angles. So how do we prove that two lines intersect to form a 90-degree angle? How do we prove that? We can prove that their slopes are negative reciprocals of one another. So we write 2 has 4 right angles, and we go ahead and prove that. So FG is perpendicular to GH if the slope of FG times the slope of GH equals negative 1. And we have 1 over 11 times the slope of GH, which is 11 over negative 1, and that equals negative 1. Okay, those two lines are perpendicular. We need to prove next if GH is perpendicular to HD. So if the slope of GH times the slope of HD equals negative 1, then the two lines are perpendicular. So let's see. The slope of GH is 11 over negative 1, and the slope of HD is 1 over 11. Multiply those together, we get negative 1. Those two lines are perpendicular. Now let's prove HD is perpendicular to FD. The slope of HD times the slope of FD must equal negative 1 in order for the two lines to be perpendicular. The slope of HD is 1 over 11. I multiply that by the slope of FD, which is 11 over negative 1, and I get negative 1. Those three are perpendicular. Let's check the last set. FD is perpendicular to FG. The slope of FD times the slope of FG will equal negative 1 if the lines are perpendicular. Let's check. The slope of FD is 11 over negative 1 times 1 over 11 gives me negative 1. So all 4 slopes are perpendicular. Therefore, we have 4 right angles. We proved both things. Yes, it is a rectangle.